is it time to panic about global warming? I'm sure you recognize it's a hot button issue again today. It was a hot button issue back in 2005 and 2006. And it was even a hot button issue back in the late 1970s. And some of you maybe remember that too. I do vaguely. And so we'll talk about that. But the question is, are we going to panic about global warming today? Some say yes, some say no, and many say, well, let's just leave it to the experts and listen to what they say and do that. I've chosen to take a different route. I've tried to look at the evidence the best I can through my worldview and try to assess whether it makes sense or not to be, how worried should we be about global warming. And so during the day today, we're going to, for the next hour, we're going to talk about, do we really know the cause of global warming? A lot of people will tell you yes, they do, and we'll talk about that. Is the temperature of the earth likely to spiral out of control? That's another concern that some people have, and so we're going to talk about that today. But probably the most important question we're going to try to answer today is this one. Should we drastically change our lifestyles in the hope that we can slow the rise in the global temperature? Okay? And so that's, I think, probably the most practical thing that we'll talk about today in terms of our lives, and does it make sense there to do that? And so as we get started now, I want to make sure that we're all on the same page. I'm going to assume that this is the dictionary definition of weather. I'm going to assume that you'll know what this is. You hear a weather report probably every day. How hot's it going to be, whether it's going to rain or not, whether it's going to be clear or cloudy. But what is climate? I want to make sure that we all understand what climate is. Here in the Merriam-Webster dictionary, it says the average course or condition of weather at a place, usually over a period of years, as exhibited by temperature, wind velocity, and precipitation. Now, they're just going on, but so what is climate? It's just the average weather over lots of years. And most people, when we're talking about climate, I want you to remember this. We're talking about climate, we're talking about generally at least 30 years, okay, when we do that, all right? And so, and this is another thing that I want to make sure that we understand. Our global climate is very complex. The climatologists, the ones that study the climate, have taken on a very difficult challenge to understand all the intricacies of what God has designed. And so, and not only do they want to understand it today, they want to predict it on out into the future. Now, how difficult is that? That's even more difficult. Even if we understand every day today, everything as it were today, how could we predict it out into the future? But that's the challenge that they've taken up, and it's an important one for us. Now, the other main another main idea that I want you to come out of this with today is that we have very limited data really on this, and we've only really been taking satellite measurements of temperature for about 40 years roughly. And so we have good data there, but then it's only really temperature data, and we're only really now beginning to understand what other kinds of data we would need to predict the climate. And so the number and complexity of the factors that affect our climate is astounding. Even the size of the raindrops make a difference when you're trying to predict the climate. And so, at my age, when I was a little boy, about 5 years old, I remember listening to the TV and saying, and listening to the weather report, and remembering how often they got it wrong and thinking, well, I could probably just as well flip a coin, right, and get as good a weather report. Well, but today, climatologists do a lot better now, right? I mean, most of the time they predict weather a day or two in advance without much trouble, okay? And now they still do get it wrong sometimes, all right? And we remind them about that, all right? But they're better. It's better now than it was when I was a little boy, which, as you can tell, was probably a long time ago. And so it's better now. But I just want you to think, though, how difficult it is to predict the climate over the entire globe, and how difficult is it to predict it into the future? And so it's an enormously difficult problem. And so here's our first attempt, if you will, to look at the weather, to look at the temperature of the Earth. And here we actually put land-based thermometers all over, temperature measuring devices all over the Earth, and have been measuring it since 1880, all right? Now, I'm not going to drown you with a lot of data today, but just a few graphs to look at. And so these data, what do you see about this? Well, in general, the temperature is rising, right? It is rising from 1880 till today. And a matter of fact, I want to make sure everybody understands right off, I believe the temperature has risen. Particularly, we know that pretty well over the last 400 years. And so it's been rising. But is it rising all the time? Well, no. It's going up, but it's generally going up, but not up at an exact rate every time, okay? And what's it risen? Roughly in the last 140 years, it's risen about 1 degree Celsius, or a little less than 2 degrees Fahrenheit, all right, over that time. But the overall trend, I want you to remember, is up. Now here's Al Gore. I'm sure many of you recognize his face. And if he were here today, he'd be trying to convince us that everybody believes that in their view, in that view of climate change, and that the temperature of the Earth is rising, and it's rising for a reason, just because humans have caused it based on things that we've done. And he would try to convince us there's a consensus, all right, and that all scientists believe that we are responsible for the rise in the global temperature. But there really isn't a full consensus yet, and if there were, we wouldn't hear dissenting voices, and we still do. That's basically how science works. And even within the scientists themselves, there's a lot of variation in what they believe, okay? And let me try to show you this. I'm not very good at this yet. I'm going to have to work on that. But as you see that dark line there on the graph? That dark line is the average of all the different calculations that different scientists have done. And you see the little fine lines up there on the graph? Those are all the different scientists, and you can see, well, is there great agreement within those scientists? No, there's not very good agreement, and what's worse is you see those boxes and circles on the bottom? That's the actual temperature of the Earth that they're trying to predict, okay? And so are they off? Well, they tend to agree, but they all tend to be, and not very well, but they all tend to be high in their agreement. So we'll look at that more a little bit later. But I just want you to understand that all scientists aren't in full agreement yet either with how things are with how things are. But I want to go back just for a minute and as to the last part of my introduction here and say the last climate change panic was in the 1970s, okay? And here are some of the words. I won't read it all, but there are ominous signs. There's drastic change. There's a drastic decline in food production. I want you to remember these kind of words. And then this goes, the longer the planters delay, the more difficult we're going to be able to cope with this climate change, and it's going to become a grim reality. Now, I want you to remember that kind of language, okay? And we're going to see that again here in a minute. But this climate change panic wasn't global warming. It was actually global cooling. Some of you remember that? Okay, a few of you do. Okay, a few of you do. And so it was actually global cooling and not global warming. And we're going to see why that is. Why are people so concerned about this? And I'm going to show you that it's a lot based on our worldviews and how that affects things. And so let's look at that for just a minute. What is your worldview? It's your perspective on the world. And matter of fact, there are a lot of different definitions out there. Some of them are long as my arm, but I've tried to boil it down for you. It's your deeply held fundamental beliefs about the nature of reality that determines how you live your life. And so it's basically your bias, what you fundamentally believe about this world. And a complete worldview contains some of these things. It should answer the important questions in life about how did we get here? How are we supposed to act when we're here? What happens to us when we die? Some of those important questions about, that we have in our lives. And a good worldview also is consistent with reality. It's consistent with what we see every day, and it's coherent. In other words, our answers to all these important questions fit together. And so if you have a consistent or good, complete worldview, it'll answer those questions. It'll be consistent and coherent. Now, everybody has a worldview, okay, but not everybody can clearly state it, but everybody has a worldview. And so we'll look at that today. But there really are two worldviews, one a biblical worldview and a secular worldview. And that's how we're going to look at this issue today. And so if you're like the man on the left here as you're looking at it, he has a biblical worldview. He stands on the authority of God's Word, the Bible. He seeks to see everything the way that God sees it. And not only does he accept the theological truths in the Bible, he also accepts the historical and scientific truths that we see in the Bible. Since, of course, the creator of the universe certainly knows those things. The man on the right, on the other hand, has a secular worldview or a naturalistic worldview. Most of them are convinced that they can examine the world today and see for themselves what was true in the past. But their underlying goal of a secular worldview is to explain how everything got here, what? Without God. Okay? So what are we doing, though? Both of these two men are doing what? They're staring at the same evidence, right? They're looking at the same evidence, but they have different perspectives, different worldviews, and so they're looking at that evidence through that, and they come to different conclusions, all right? And that's particularly true in subjects like we're talking about today, which are far in the past, which we'll look at, and far into the future when we're talking about climate change, and we're talking about the fundamentals. We really need to know what happened a long time ago, and we really need to know what's going to happen into the future. And of course, do any of us know what's going to happen in the future? Of course not. And so when we're talking about science in this regard, it's not surprising that people's worldviews affects how they see the scientific evidence. And so let's first start with a secular perspective. And what is the secular perspective? You start out with the Big Bang, right? And the Big Bang was about, 13 or almost 14 billion years ago. Hard for us to imagine. But there was a Big Bang where in the beginning there was nothing, and then nothing exploded, if you will, or everything. It cooled down, that Big Bang, it started to cool down. Stars were formed. Finally, our sun was formed about 4.5 billion years ago, and the Earth about that same time. And then somehow the Earth, even though it was molten 4.5 billion years ago, somehow about 3.8 billion years ago, it was covered with water. Now, how in the world could all that water have gotten there? It's a real challenge for the scientists to explain that. And we'll look at how much water is there later. But it's an astounding amount of water, as you well know. And so that's the secular view of history. And of course, as that water got here, then weather could have started. Of course, we don't know what was in the atmosphere, what the atmosphere was made of, if there were a 3.8 billion years ago in history. Okay, and so there are consequences to that worldview, though, and I want you to try to understand this is an important point to grasp. If random forces produce the earth, and that's what a secular worldview would say, right? That all these molten things came together, conglomerated together, and made an earth. It cooled down, and somehow water got here. And so if random forces produced the earth and made it suitable for life, then what? Random forces could just as easily make the earth uninhabitable. that make sense? And so if you have a secular worldview, then it's not surprising that you would be concerned about what's going to happen in the future, or more concerned, because, and if there is no God, then who's going to save the earth? Well, the only ones to save the earth are the people here on the earth. And so from a secular perspective, that's what you would need to come up with. And so I want you to look at that. And so we're going to look at that secular perspective now, and what some of the folks from a secular perspective would say about the earth. And so as we go back again to the question, is it time to panic about global warming? You won't be too surprised that some are concerned, right? Here was a cover of Time magazine back in 2006 when, as I said, that was one of the other hot button times when this was a hot button issue. And what does it say? Of course, you have your polar bear up there, and then it says, be worried, be very worried. Climate change isn't some vague future problem. It's already damaging the planet at an alarming rate. Okay, and so, but what they didn't know in 2006 was that the next 2 years, the temperature of the earth dropped pretty dramatically over the next 2 years. And so that's how the switch went from global warming to climate change. You'll see a lot of, in the literature at that point, beginning it was talking about global warming, but now talking about climate change because it fit better the narrative that they wanted to do. But I want you to remember, though, the temperature still is rising over the past 400 years. But what is the focus of the people writing the literature? Their focus is the next 5 minutes, right? Not the last 400 years. And so that's what we often see in the mainstream press. We see a headline, but then not put in perspective. And that's what I want to try to help you see today. Okay, and then let's look at a scientist, a very famous scientist, Stephen Hawking, theoretical physicist and cosmologist. And he said this back in 2006, the danger is global warming may become self-sustaining if it hasn't done so already. We need to urgently reverse global warming if we still can. And so even the famous scientist is looking at this and say, maybe it's going to get out of control. I don't know. And then the political perspective, a very recent one, once you may have seen, the world is going to end in 12 years if we don't address climate change. And Alexandria Ocasio-Cortez, very young, new representative, and stating her opinion on that and gaining a lot of attention. I suspect we're going to see a lot of her over the next few years. And then you'll see on the NASA website, you might be a little surprised, but they're very interested in this subject too. And you can get a lot of good scientific data from them. And what do we see on the NASA website is that we're seeing higher carbon dioxide levels, and carbon dioxide is steadily rising. And it's 0.041% today and rising at about 0.002% a year. So is carbon dioxide at a high concentration? Well, no, but it is an important part of our atmosphere. About 1 in 2,500 molecules in our atmosphere is carbon dioxide. Okay, so 1 out of 2,500 molecules, if you're able to pick them out of the air, would be carbon dioxide. And then, is the sea level rising? Yes, it is, and the sea level's been rising for quite a while, at a fairly steady rate at about 1/8 of an inch per year. Okay, and so that's 1/8 of an inch. So every 8 years, it would be up roughly 1 inch. But then put into perspective, if you look in the history of what scientists believe, they believe that the sea level was actually 100 meters or around 300 feet lower than it is today. And so these seem like relatively minor changes given that perspective. And then finally, as we've already seen, the global temperature rising almost roughly 2 degrees Fahrenheit since 1880. And so you see a lot of that on the NASA website. And you can get some good information, but clearly on the side of of a global warming enthusiast there at NASA. And then one final thing I forgot to mention earlier, our young people are actually also starting to pay attention. They've been taught now for a long time that we are the cause of the temperature rising. And some of them are paying attention and thinking that they really should pay attention to this issue. And Greta Thunberg, she may be the face of global warming here in the future. She's a 16-year-old from Sweden, and she got so worried about this and her life, and it really had her panicked. And she decided to stop going to school and to start protesting in front of the Swedish government every day. And she did that, and she finally got a following, and people are recognizing her on the internet. And you may even see it coming into the United States. I don't know yet, but students are now taking some Fridays off in Europe and in Canada and protesting for climate, that we need to do more on climate change. But I do admire Greta Thunberg, though. She is doing what many are not. She's actually changing her lifestyle based on what she says she believes. All right? And so, to me, she's got my respect. I don't believe we have a climate crisis like she believes we do, but I admire what she's doing. They invited her to the Economic Forum in Davos, Switzerland, and so she accepted, but she wouldn't fly. She thought she doesn't fly anymore. And so she took a 32-hour train ride to Davos, and then she wouldn't go in the hotel room they'd reserved for her. She camped out instead, out in 0-degree weather, and then told them things like this: I want you to panic. I want you to feel the fear I feel every day, and act as if your house is on fire, because it is. And so she's taking it very seriously and very concerned, as some of you may be. And so, but that's Greta's perspective on the issue. Now I want to change gears now. That was a secular perspective, and I want to look at a biblical perspective for a minute. And what do we know from the Bible? That God created everything in 6 days of ordinary length, and not that long ago, based on the genealogies or the family trees in the Bible. And so, excuse me, it's a very different perspective than we see from the other. So is the earth designed now? From a biblical perspective, we'd certainly say that it is, not that it came about by random forces. As a matter of fact, these two perspectives can't hardly be any more different than they are here. One says a very long period of time, random processes brought us here. The Bible says no, a very short period of time, not that long ago, and it was caused by the God of the Bible, a supernatural process. And so, is it time to panic about global warming from a biblical perspective? And I'd say no. Matter of fact, from a biblical perspective, it's not time to panic about anything. God is in control. And the other thing, and I'll try to show you, climatology, as we're going to look at the data, is a young science, and there's much that we don't understand yet. And so, even just from a scientific perspective, it's hard for me to understand why we would want to panic at this point. And so what does the Bible say? In Genesis 1:28, it said, "And God blessed them, and God said to them, be fruitful and multiply, and fill the earth, and subdue it, and have dominion over the fish of the sea, and over the birds of the heavens, and over every living thing that moves on the earth." And so what's God done? He's actually given us some responsibility along with Him to take care of the earth. And that's a responsibility that we should take seriously. And if we find that we are harming the environment, we should be willing to change based on this biblical perspective. And certainly, what else should we just use up our resources when we don't even need them? Of course not. We need to be good stewards of the resources that God has provided for us. And so, even that, I think we can agree on with the folks with a secular perspective, that they believe we ought to use resources wisely also. Okay, and so from a biblical perspective, again, the 7 C's of history, I don't know whether you've seen this before or not, it's a good way of remembering the history of the Bible, starting with creation. God made everything very good. Then Adam and Eve sinned, brought corruption, brought sin into the world and death. And then there was a catastrophe at Noah's Ark, of the global flood. And I hope you do take the opportunity if you haven't already. Who's been to the Ark already? Most of you have. Fabulous. Great. And so I'm glad you've taken opportunity to do that. And those two, the creation and the catastrophe, as we're going to see, are the two C's of history that are actually going to play into this issue of climate change the most. And I'll show you how that's going to go here in a minute. Okay. One more thing. As I said before, God made this planet to be inhabited. Isaiah 18 says, He did not create it empty. He formed it to be inhabited. I am the Lord, there is no other. And so God created this world and designed it for life, not a random process. And did He do that and then go on vacation? No. Colossians 1:16 says, For by Him all things were created. And at the bottom we see, and in Him all things hold together. So God is actively holding together this universe all the time. And so that's a biblical perspective. And finally, I want you to remember this one as much as any other scripture that relates to this subject. Genesis 8:22. While the earth remains, seed time and harvest, cold and heat, summer and winter, day and night, what? Shall not cease. And when did God say this? After the flood, right? And so He's given us a promise that while the earth remains, all these things, and if all these things remain, harvest, cold and heat, summer and winter, day and night, if we can grow food, then that's going to be a reasonable environment in which for us to live. And so that's a promise that God's made to us. And I think it's a very important one to remember when we're looking at this issue. So the summary, real quickly, is the biblical perspective. God created the earth a few thousand years ago with a purpose to be inhabited by man. God's promised to do what? He's promised to keep the earth suitable for life until there's going to be a new heavens and a new earth. And God has shared with us the responsibility of taking care of the earth, and we need to be diligent and take that responsibility seriously. The secular perspective is totally different. The earth's history spans billions of years, not thousands. It was formed by random, unguided processes. At any point, the random processes could make, in that perspective, the earth uninhabitable. And it's up to the people to understand what's going wrong and to try to fix it. And so you can see these two diametrically opposed perspectives on climate. So now let's look at the data a little more and look at the scientific data very quickly and show you a few things about that. But first, I had to put you up a polar bear again. That's just a requirement. If you do a global warming talk, you have to have a polar bear. But I put this one up for a purpose this time. I want you to think about that. Why is that polar bear up there on that piece of ice? What's he doing? Okay, what's he doing? Is he hanging on to that last piece of ice there is in the Arctic? Or is he trying to get a better perspective and see who's taking his picture? Okay. Now, I wonder, but I suspect it's probably the latter. Polar bears, of course, can swim many miles. But so again, your perspective on things matters, and that's what I want you to remember as we go along. Of course, if the climate does continue to warm, some of the habitats for the polar bears may go away, and they may have to go back to land at some point. Okay. And so before we look at the data, though, what I want you to understand is that accurate temperature measurements of all over the globe is not easy. Let's think about that for a minute. And how would we do that? How would you determine an average global temperature? Well, you'd have to have reporting stations all over the earth. And they'd have to be giving you a temperature measurement at one time because half the earth is going to be in day and half the earth is going to be at night. Some storms are going to be going on in some places, some wind, a lot of things that would affect the weather. And so cloudy, clear is going to affect things. And so it's not an easy thing to do. And so we're going to look at different ways that the climatologists have tried to measure how temperatures are, what the average temperature of the Earth is. And what I want to show you here is just, these are the satellite data that I was telling you about. This is the best way that scientists have found so far to measure the average temperature on the Earth. And they have satellites, and they can look at a lot of different places on the Earth at the same time. And this is, but we remember, a climate is 30 years at minimum, right? And how much data do we have? We've got a whole 40 years worth of data. And so it's not enough really to make accurate models yet. But what do we see about the temperature? Overall, again, is the temperature slightly rising? Well, kind of overall in those 40 years it is. It's about 1 degree Fahrenheit, or maybe a little more. But what do you also see? You see a lot of variation within the years, right? So a lot of bouncing around in temperature. And you see the Mount Pinatubo, that was a volcanic eruption, and that put a lot of dust in the air and reflected some of the sun's heat away from us. And so the temperature went down a little bit. El Nino, the currents in the oceans in the Pacific, actually changed the temperature in a short term there. And so events on the Earth can also change that average global temperature. And so this is the best data we have, but we only have 40 years. So what are we going to have to do? We're going to have to go back and look at more data that we're less sure about. And I showed you this earlier. This is the data. Now, these are measured on the Earth. But what happens on the Earth, a lot of times, the surroundings around these temperature devices change. More people come, and so it changes that, and they have to correct. And so these are corrected to some degree, but these are the best data we have on the Earth. And before 1880, it's even less sure, and I'll show you a little bit about that. But do you remember back when I told you about global cooling? They were panicked about global cooling. Well, let's look on the graph here. It was about 1980, and what had the temperature been doing for several years before 1980? It had been going down a little bit, right? And so what did the scientists do? They said, well, the temperature's been going down, and we're going to have a short-term focus, and we're going to be we're afraid it's going to go down and continue to go down, okay? And so the short-term focus, again, even though the overall trend was up, some people looked at that and said, oh, maybe it's going to continue to go down. And what are people doing today? Well, they're looking today, and it's continuing to rise, right? And so they're going to say, well, maybe it's going to continue to rise for a long time. But again, can we predict the future? We can't. And so I want you to just understand that extrapolation beyond the data that you have is dangerous. And you can easily be wrong. And as a scientist, I've done this, and I've been wrong when I did that. And so, well, what are we going to do? We really need a longer-term perspective than this to get a good model of the climate. So what do we have to do? To go beyond that, we have to go to data that just correlates with temperature, because we didn't make temperature measurements before 1880. And so what do we see here? If we look, I think I mentioned the little ice age in around 1600, something like that, maybe 14 to 1600. And what did we see back then? We have historical accounts that the temperature was low back then. As a matter of fact, the Vikings went from northern Europe over to Greenland. If we back up to the year 1000, and they were actually being able to farm in Greenland. And so 1,000 years ago, the Vikings were able to farm in Greenland. Can you farm in Greenland today? No, it'd be pretty tough. There's a lot of ice. Greenland is mostly ice covered. But then the Vikings went away, and then we see a lot of the historical evidence of the little ice age. So back in Europe, the Thames River in London actually used to freeze over. And it did that. It did that in the little ice age. So we have good historical evidence that the temperature was lower, particularly in Europe around the little ice age. And of course, it's risen since then. We don't see those things. And we have historical evidence of the Vikings who went over to Greenland and farmed around the year 1000, But around the year 1200, they went back because Greenland was getting ice covered again. And so we have data back even further, but if you look at this further back data, it looks more like a cycle rather than just climbing, as we looked at earlier. And so I just want you to help you see that perspective, your perspective matters in what you look at. Okay, and so for the rest of the talk today, good, I want to talk about these three things, and I hope I'll get to the last one. Well, number one, man-made CO2 is not likely the dominant cause of the current temperature rise. And that's opposed to what a lot of scientists say, and let me show you why I believe that. Then we're going to look at the Earth's climate is brilliantly designed, and I want to show you some amazing things in the design of the Earth and why the temperature is stable as it is. And then finally, if we have time, I want to show you how biblical history better explains an ice age than the current scientific data does. Okay. And so global warming, you need to understand the greenhouse effect. You don't need to understand all the writings on this. I just want to show you this. But what is a greenhouse gas? It turns out that the sun generates energy. It sends the energy to the earth and warms the earth. And when the earth gets warm, what happens? Like all warm things, it releases radiation, infrared radiation. And that infrared radiation goes back up into the atmosphere. And a greenhouse gas actually absorbs some of that energy and reflects it back to the earth. And so I want you to think about a greenhouse gas like a blanket over you when you go to bed. What does a blanket do for you when you go to bed? It takes some of your body, your body's warm, it's generating infrared radiation, but your blanket holds some of that heat in and reflects it back into on your body and keeps you warm. A greenhouse gas is just the same, and so CO2 will absorb some of that infrared radiation and reflect it back to the earth and keep us a little warmer than we otherwise would be. But the thing that scientists don't often tell you is if we didn't have all the greenhouse gases, the earth would be about 60 to 70 degrees Fahrenheit cooler than it is today. Now, would that be a problem? That'd be a problem, wouldn't it? And so it turns out that we need the greenhouse gases to do that. And what is the major greenhouse gas? In the literature and the papers, they would tell you what? CO2, right? And CO2 is the major greenhouse gas. But that's not actually true. Water vapor and the clouds are actually a bigger effect in terms of the greenhouse gases than CO2 is. And they say, well, we can't do anything about water, so we're going to ignore it. But I want to help you try to understand that the effect of water is actually greater than the CO2 effect, particularly from man-made CO2. And so roughly 85% of the greenhouse gas effect is actually water. And man-made CO2 is very low. But the scientists feel like that we can't do anything about water, and certainly water is with us to stay, but they concentrate on the CO2. But I want you to think about this for a minute. If CO2 were the issue, then why would it have been warm back in about 1000 AD? Was man generating a lot of CO2 back at that point? It doesn't seem likely to me, and I tried to make up this graph for you to help you understand that if we look back before 1800, the global temperature was declining, but the amount of CO2 was about the same. And so now if you look at just the last 100 years or so, what do you see? Both CO2 and temperature are climbing, and it looks like they're correlated together, and that's why scientists are saying that they are. But if you look back earlier, we don't see that correlation with CO2 and global temperature. And so that's one of the reasons I'm not as convinced as others are. And the other reason is because of all the variability and the lack of prediction of temperature of the models that we do have so far. And don't get me wrong, I'm not trying to throw shade on the climatologists. They have a very difficult problem that they're trying to do, and we don't have enough data. And the trouble is, even if we had enough data, our computers right now are not big enough to predict the global climate situation. The computing power is just not strong enough. And George Bach said it this way in a famous quote of his. He says, all models are wrong, but some are useful. Okay, and so that's true, because anytime you're modeling something, your model is going to be not exactly like the thing that you're trying to model. I did this a lot when I was at Eastman Chemical working there. I tried to make models of our different processes. And when I didn't have enough data, my models were pretty bad. Okay, and that's what we're seeing with the climatologists today. And certainly the models will get better as time goes on. So should we be panicked if the current temperature of the Earth is similar to what it was 1,000 years ago? Should we be panicked if our mathematical models are biased toward predicting higher temperatures, which, as I showed you, they were? And if CO2 has not always been correlated with the Earth's temperature, and if man generates a very small percentage of the total CO2. And so for those reasons, I'm not as convinced as others are about the correlation between CO2 and the rising Earth's temperature. Okay, the second one, Earth's climate is brilliantly designed. I want you to look at the sun here for a minute. What is it? You've heard about the sunspots, right? And the 21 or 11-year cycle of the sun. It turns out that is true, and we do see a very, very slight change in temperature over the cycle of the sun, and we see it there. But what has God designed? He's designed a star, the sun, if you will, that generates almost exactly to 99.9% the same amount of energy every day. The sun actually provides almost exactly the same amount of energy every day, and it just happens to give us the energy that we need in terms of the light and the heat that we need. It doesn't burn us up, and it gives us light to see by. And so, to me, it's a fabulous design and creation. Psalm 74:16 says it this way: yours is the day, yours is also the night. You've established the heavenly lights and the sun. And he did. But I want you to look at this. This is a temperature plot of the different planets that we have and their temperatures here. And what do we notice? That, of course, the further away you are from the sun, the colder the temperature, right? And the closer the sun, the higher the temperature. The only reason Venus and Mercury are out of order is because of carbon dioxide, actually. But let's think about this for a minute. Everybody says, well, the Earth is just exactly the right distance from the sun. Well, okay, let's think about the moon for a minute. How far is it away from the sun? It's essentially the same distance as we are away from the sun, right? But what about the temperature on the moon? The moon is 250 degrees Fahrenheit positive during the daytime and roughly 250 degrees below zero at night. What do you think about that for a climate to live in? Not very good, right? We'd be in tough shape if we were trying to live there, that shape. And so the Earth is in the right place if you take into account the global warming, the greenhouse gases, and the water. It turns out the water on the Earth makes a tremendous difference in our climate, and the difference between day and night temperatures is very much modified by water. And I believe water is the key to the temperature stability of the Earth. The evaporation and condensation of the water helps move the heat from the sun around so that the temperature on the Earth is more or less the same. And the oceans, the Earth's surface has 320 million cubic miles of water. Now, I want you to think about that for a minute. I want you to think of a box that has a mile in each direction, okay? That holds about 1 trillion gallons of water in that, if you can picture that in your mind. I know it's hard to do. And so we have 320 million trillion gallons of water on the Earth. It's an astounding number. But that amount of water helps control the temperature of the Earth, because it's very difficult to change the temperature of that much water that fast. Matter of fact, water has that property. It's very difficult to change its temperature. And so that, to me, I believe, is also a part of God's miraculous design. Water also is another important part, for Job 36, 27 and 28 says this: For he draws up the drops of water, they distill his mist in rain, which the skies pour down and drop on mankind abundantly. What's God figured out how to do? We've got the water in the oceans, and the water in the oceans is salty and not all that valuable for us, but what's God figured out? And in the design, right, this water cycle, and you know about it, it's the water from the oceans evaporates, goes up and forms clouds, and then the water comes down. And it goes into all these different places. But what's God done? He's got all this water that's not all that useful to us. What has he done? It evaporates, and only the water goes up. The salt stays behind, and we get fresh water for all the different uses on the earth, for people, for plants, and for all the things that we need. And so again, a brilliant design of getting us what we need in the water cycle. Another thing is carbon dioxide is critical to life. I want you to think about that for a minute. What on this earth depends on carbon dioxide? Do we know? Plants do, right? So plants, if we didn't have any carbon dioxide in the atmosphere, how many plants would we have? We wouldn't have any. What would happen if there was no plant life on the earth? There'd be no us either, would there? Right? No animal life either. And so we have to have carbon dioxide in the air for that to happen. And, oh, by the way, all that photosynthesis that goes on is another brilliant design. But in the air, carbon dioxide is only in trace quantities, as I told you, 1 out of 2,500 molecules. Today, that's 400 parts per million, roughly. When we get down below about 180 parts per million, plants don't grow very well. And so it's critical that it is above 180. But also, and it doesn't really slow down. As you can see, it affects the rate of plant growth here, the amount of CO2 does in the atmosphere. And so as it goes up, the plants will grow actually faster. And I'll leave that there for time. Jeremiah 10:12 says this, "It is he who made the earth by his power, who established the world by his wisdom, and by his understanding stretched out the heavens." And so for me, this earth is a brilliant design. Let me skip that. Let me go on to this real quickly, and then I'll end up. And I'll have to do this quickly. Biblical history, I contend, better explains the Ice Age than the scientists. The scientists have a problem. They think that the Ice Ages just happened when the earth got colder. But there's a problem with that theory. If the earth gets colder, you do form some ice, but there isn't very much water in the air when the temperature gets colder. Have you ever thought about that? On really crisp winter days, is there much water in the air? Well, no, the humidity's like very low. And so where's all the snow going to come from that generates the ice for an ice age? And so it turns out what you really need is you really need a warm ocean and a cold continent. Well, how in the world would you have gotten that? And I don't have time to explain it all today, but let's look at this for a minute. Let's look at the global flood, the catastrophic global flood, and you'll see some of that here and at the ark. And it looks like from the scientific evidence that lava at the bottoms of the ocean, that those ocean floors spread open, and that lava actually contacted the ocean water. And so what would happen if lava contacts that water? It's going to make steam, and it's going to shoot up into the air. It's even powerful enough that the water could have made steam and shot up through the air, even through the oceans. And so, to me, that actually speaks to the fountains of the great deep when you see that in the biblical account. But what would that also do? It's going to raise the temperature of the oceans, right? So it would make a warmer ocean. And if we had all that tectonic plate movement, all the plates on the earth moving, we're also going to have, let me show you this picture. Whoops, real close. You see these mountain ranges underneath the ocean there? People have just in the last 50 years have scientists seen these? And these mountain ranges are all over the earth and roughly midway between the continents. And I don't have time to talk about that today. But scientists believe that that's where the ocean floor is separating, and this lava is coming up and touching the water and being cooled and finally building these mountains, but at the same time really warming the ocean. Well, if they did that with all this tectonic movement, there would also be volcanoes, because volcanoes come with tectonic movement too. And so if you had volcanoes, what do? They spray dust up into the air, and what does that do? That blocks the sunlight and cools the continents. So what did I say we needed? Ideally, we need a warm ocean from the lava touching at the bottom, and we need a cool climate, a cool continent for that snow to fall on and make the ice age. And so to me, it actually explains one ice age better than do the scientific data. And so to me, that was just fascinating to look at that. One final thing as we end up here, what is, let's say that, let's imagine that we could control the temperature of the earth for a minute. We can't do that, but let's just imagine that we could. What is the right temperature for the earth? And who gets to decide? I remember I gave this talk in Peru one time, and I said, well, should the Peruvians decide what their global temperature? They said, yes, of course. And I said, well, what about all the people in the rest of the world? Oh, we don't care about them, And so even then, even if we could control the temperature of the earth, where would we control it? Okay, and so I want you to think about that as you're thinking about this issue. And as I wrap up here, I just want to encourage you to look at a lot of the resources that we have here at the Creation Museum. There's a good DVD on global warming. There's a good pocket guide. These are very inexpensive on global warming. I'd encourage you to look at. I talked about the 7 C's of history also. I'd encourage you to look at those. If you're just getting into this for the first time, though, and looking to get some just basic fundamental information, I'd really encourage you to get these answers books, because what these answers books are, what we've done is answered the most popular questions of folks like yourselves who have come in and said, here's what I'm interested in. And so what we've done here at Answers in Genesis is make a chapter to answer each one of those questions. So if you can, get all these answers books. If you can't get as many, get 1 or 2. But I encourage you to get these, and they will answer many of the questions that you have. The Lie, written by Ken Ham, the CEO here at Answers in Genesis, very well written. If you're interested on these worldview issues that I didn't really have time to talk about a lot today, Ken's book, The Lie, explains that very well. And The Flood of Evidence is a good book talking about the evidences for the flood. That's a much more recent book. And there, if you don't like to read, I'd encourage you to get this DVD series by Ken Ham, a wonderful communicator here at Answers in Genesis. Some of you have gotten the handouts, I think, for the Answers magazine. I'd encourage you to get that. It's 6 issues a year, has a tear-out section for the children, for the younger children, but keeps you up to date on a lot of the issues in this area. Let's see, what else? Oh, The Glass House is another very recent book. If you have some of the more fundamental things, I'd encourage you to get this one. Very recently written. Ken Ham and Bodie were the editors on that. Shattering the Myth of Evolution. A lot of good chapters in there on that. Answers Insider, free to you. Just fill out that and get that. Ken talked about, whether you saw the promo before this, on PureFlix, where you put PureFlix together. It's a family-friendly Netflix, if you will. Goes together with Answers Magazine. A lot of good value there. And one final thing for the women, Answers Conference for Women, Truth, Undercovering the Lies We Believe. That's going to be in March of next year. I certainly encourage you ladies to do that. And just as I finish up here, I would just encourage you today to think about these issues, think about the global warming issues, think about the different worldviews, and see where you come out. But to me, there's very strong evidence, I believe, that the Earth's temperature is so complicated, and at this point, it's very difficult for us to really understand where it is and where the scientists, I don't believe we're quite where the scientists think we are today. Thank you for your attention.